So also kind of encapsulated a little bit in the development strategies chapter was this idea of the financial analysis. And I don't want you to get all bent out of shape out of the financial analysis isn't that hard, but I just wanted you to sort of get exposed to this idea. So what we're going to do here is I want to talk about economic feasibility. Now, we talked about feasibilities already. We had scheduling feasibility, operational feasibility, technical feasibility, and economic feasibility. So this is sort of a little bit deeper into economic feasibility. We're going to talk about the costs and benefits and well, chargeback methods, but I guess I was trying to get to that. There it is, payback analysis, the ROI, so return on investment, and then present value. It's sort of a way that, given multiple projects, you can make a decision as to which project, it'll help you make a decision as to which project you should be working on. Now, systems analysts are required, in theory, to look over the costs and benefits throughout the phase. I mean, there's project managers are doing that for sure, and of course, management itself are potentially doing this. These are, if you're in scenarios where we're actually they're project based. I mean, every now and again, you know, when things break, we still have to figure out, is it worth fixing it? So the maintenance, when things break, is it worth fixing it? Or, but in this case, I guess the context you want to put this in is we're going to go build a, what do you guys, not customer, come on. Student courses, a course, we're going to build a course management system. Is it going to be worth the cost? And so we're going to look at that, and we're going to try and work out the total cost of ownership, or TCO. So they actually got some kind of neat discussion a little bit about Amazon. That's somewhat new to the material, but I want to talk a little bit, first of all, about different kinds of costs. So you got tangible and intangible costs. Obviously, a tangible cost is how much they're actually paying you, the developer, for being there, right? That's a tangible cost. Also, if you buy any hardware or licenses. And then intangible costs are typically, well, harder to measure. So dissatisfaction by the customers or the employees, they got to be factored in, but it's not going to, intangible costs aren't really going to come up too much in this part of the analysis, because we're looking at the financial part, the financial cost analysis. So we'll be looking mostly at tangible costs. And you also have direct costs, which are costs going straight to the project, and then indirect costs. So a direct cost, again, if someone buys the machine for our course management system, that's a direct cost. The place that the machine is sitting, and and by that I guess I mean the cooling, air, ventilation, or even just simply the real estate that that machine is sitting in, would be an indirect cost. In the case of our course management system, the salaries of the developers would likely be a direct cost, but then the people maintaining the infrastructures, that's indirect costs. So you got, so going back here, you got tangible and intangible, direct and indirect, and then the other one here is fixed and variable. So again, you buy a machine, there's a fixed cost. But, and actually we'll use our example, the printer. If you buy a printer, that's a fixed cost. But now from that point on, any time that you're buying not so much printer paper, but printer ink, that is your variable cost. And we all know the deal there, right? You buy a cheap printer because it's cheap, and then you realize that your variable costs are huge because the ink for that cheap printer is expensive. So that is sort of fixed and versus variable. And then you finally got the development cost and the operational cost. So again, development would be how much it is spent actually building the system. Operational is how much is spent actually running the system. So it's true, direct tangible costs are a lot easier to identify and predict than indirect and intangible costs. And if you're dealing with accountants, a lot of times someone's got to pay for those, and sometimes they actually have to charge back the cost to some other area in the business, right? If you're building something for a customer, that's pretty obvious, right? The customer will pay for it. If your customer, or I like to consider them partners, if they're inside the company, if you're building something for somebody inside the company, I don't like calling them customers. I like calling them partners. But either way, you're going to have to charge back that cost to them. Another sort of example, fairly easy to understand, is if you got 5 developers and you need a 6th developer, sometimes another option, which I didn't really cover, is you can pull from another team, but they're paid for under another budget. So what happens is you pull that person into your team and then pay from your budget into that other person's budget. That's another sort of chargeback. Okay, they got different examples here of benefits. Obviously, here's positive, which is like increasing the money and service, etc. Cost avoidance. So one of them is a direct positive thing, like we will make more money. Another one is cost avoidance, as in we will waste less money, right? So that's sort of the 2 examples there. And so once you kind of got all this kind of stuff done, you're going to, at some point, want to try and figure out how long will it take for this system that you're building to pay itself back. And so there's something called a payback analysis. And I just want you to sort of see this graph. This graph's a pretty good graph. It's sort of showing you the cost over the phase of the system. So here's us developing. Well, I guess first of all, this is cost, this is time. Okay, so we're moving forward in time. These are different sort of phases, the development, and by the way, in there, I would argue that you have everything up to the maintenance. So you're going to have the planning, the analysis, the development, and the implementation will all be sitting in here. And then this is basically the maintenance. Now, notice, of course, when you're first building the system, it's going to be pretty expensive, but the cost never, ever goes down to nothing. A system will almost always cost you something, especially as you start using things like IaaS and PaaS and SaaS. When you start using all that kind of stuff, you're going to get some constant cost. And then what happens at the end of your system's life cycle, all of a sudden it starts to cost more. What's going on? Well, what's going on now is that your system cannot keep up with the change in business or change in technology or something. It becomes increasingly expensive to actually maintain until finally you're not maintaining anymore because you've retired it. So that's kind of the life cycle of a system. You spend a lot of time up front, a lot of money up front, I should say, building the system. Then it kind of goes into a sort of maintenance mode, and then it gets retired. And I don't think it's ever quite as direct as this. I think sometimes you'll see like spikes in activity as different things happen. Because no system, no matter how well you design and build, is going to be maintenance free. So what I want you to see here, this line here is the graph that we just saw. This is a new line to us. This is showing the benefit. So back here, this was the cost over time. This is now the benefit over time. Now, sometimes the benefits are very easy to measure. For example, I built something that once it was finished was able to replace 3 full-time employee salaries. I felt guilty about it, but that's what I was able to do. So that was the tangible benefit would be in the beginning, not too much, but at some point now I'm basically making as much as we were spending. I guess that'd be kind of cost avoidance, by the way, benefit. But I'm basically making as much as we were spending. I'm basically replacing the salaries that we were paying those people. So if you take the benefit line and you take the cost line, you'll see at some point, and by the way, you're summing up all the stuff underneath, at some point, the system pays itself back. And that's called the payback analysis. So at some point, the amount of area here is equal to the amount of area here, and the system pays itself back. And so here, what they've got are sort of 2 analysis examples. There are 2 projects, A and B. 0 is basically when you first started. A year is now 1 year in. So 1 year in, 2 years in, 3 years in, and so on. So in the first years we were developing it, this thing cost $60,000 to build. That's the cumulative cost. The next year, it didn't cost us $60,000 anymore. We're now probably starting to use it. It's $70,000. So the cumulative cost is 60 plus 17 for 77. And so you can see that after 6 years, we are predicting that this system will cost $181,000. Now, At the same time, in the beginning, we were getting some kind of benefit. Not too much, but some kind of benefit. But then as we started using it, we seemed to be getting about $30,000 to $40,000 of benefit. So we're seeing again in the beginning, 3,000. After a year, it's 3,000 plus the 28 for 31. And this goes down and down, down. So we can see after 6 years, we got more benefit than we paid for it. That's a good thing, right? That's optimal. I know so much about years, by the way. I can't imagine. Well, I don't know. I've written stuff that's lasted 15 years, so I guess that's possible. But anyway, so here's what I'm saying, though. At some point, you're going to see it's going to pay itself back. Now, on certainly year one, it didn't pay itself back, right? I mean, it cost $60,000. We only made 3. Year 2, it cost $77,031. So half of it is, well, under half is benefit. Now we're at about 2/3. Now we're really close. So year 3 is really close. Year 4 is even closer still. It cost us a titch more, but we finally, probably the first quarter of year 5, finally pay it back. So we know that the payback here is the first quarter of year 5. If we look at Project B, it's the same kind of stuff. We didn't get any benefits the first year, but we start to see again at the end, we are going to make more money. But where are we going to make more money? And we can kind of go down here and notice that really the benefits outweigh the cost. Again, by the way, it looks to me like it's outweighing the cost in year 5. I couldn't tell you if this first quarter or not, but that's sort of an example there. And they kind of go through on how to do this in a spreadsheet. So hopefully you got enough spreadsheet knowledge that you can do cumulative totals. And then there's a nice little graph, right? Cool. Now, what's the return on investment? Well, a return on investment is if you take the total benefits and subtract the total costs over total costs. That's your return on investment. So let's just have a quick look here. And what you can see is that, I mean, both projects nearly finished at the same time, but the total here is that this ROI has got a larger return on investment. So you might make the argument that Project B would be a higher priority to do than Project A, right? So if you take, again, the total benefits, subtract total costs over total costs, 70%, this one 33%, you want a higher return on investment. And they take you through that on a spreadsheet. Now, when you're dealing with time frames of like 6 years, you're not necessarily getting what the present value of the system is because we have inflation. We don't have that much inflation, but we have inflation. So if you talk to your accountants on inflation rates, you can start working out what the inflation rate is per year. And is this going to show us? It is going to show us. But before, let me just again go back. Just to be clear, like $1 at 6% a year later is only, if the inflation is 6%, $1 this year is only 94 cents next year. That same dollar this year in 10 years would be about 55 or 56 cents. That's what that means, okay? It's pretty important. Check it, well, I don't know about important, but yeah, inflation's a thing. And so if you're trying to predict larger time scales, you're gonna wanna think about that. And so what they've done here is they basically said, okay, here is our, the benefit, the cost, you'll recognize that from the project. In year 1, it's 60. Now in year 2, where the present value's not, it's being discounted by about, I don't know, by about 10%. And so on and so on and so on, until we find out ultimately that by the time we're finished, in present dollars, this thing will make about $1,900 or basically $2,000 in present dollars. And in Project B, we're seeing in present dollars about $5,000. Another push basically for Project B. Okay. And there's the spreadsheet. One more thing, I don't know where this was or not, but I should take a step. There's one other term that I want to make sure that we covered. And I'm flying way back to here, the cumulative cost. This cumulative cost, this would be the total cost of ownership of project A and the total cost of ownership of project B. By the way, notice that project B is actually more expensive, even though it's got a larger ROI and in net present value is more. So total cost of ownership, something to help you explain this. I bought recently I don't know. Anyway, I bought a $6,000 car. It was a rush buy. I had to get it. I was under a lot of pressure. You know what? I've been buying cars now for about 40 years, and I got screwed. So yay, it took me 40 years to get screwed. But here's the deal: that $6,000 car, was that the total cost of ownership of the car? Of course not, right? I had to buy the car. I had to sink thousands of dollars into it to basically get it fixed. I have to pay gas on it. I got to pay insurance on it. I've got to. I have to pay parking at Hennepin Tech and Dakota Tech. I got to pay parking. So there's a cost to basically owning that car. And if you add all those up, that's the total cost of ownership. And so that's the other term that you kind of need to know. So return on investment, payback analysis, present value, total cost of ownership. Right. So those are all the topics there that were sort of covered here. So this was it was a piece of a chapter. It was a piece of the development strategies chapter, but I think financial analysis is kind of important. And I will tell you honestly, when you work in the industry, it's hard, especially trying to work out the tangible and intangible benefits. It actually can be rather hard to do. The last job I was at, they kind of hid most of that from us, so we didn't really know what some of our costs were. We had to sort of make some guesses. But anyway, hopefully that won't happen to you. All right, so that's it now for design strategies, and then we'll just move on now, leaving this phase and go into the design phase.